Alright, so in this video I'd like to talk a little bit about CX packet weights. And you can see my big red warning there that says don't touch the MAXDOP. Let's leave that setting alone for now. So what is a CX packet weight? Firstly, it's one of the most frequently occurring weight types that you'll see when you begin looking at waiters on any SQL Server instance. That is, any SQL Server instance that has parallelism in place. And a good way to tell that a box has been, MAXDOP has been set to 1 and they've removed parallelism from the server is the absence of this waiter. So CX packet weight simply means parallel operations are taking place, which is a very good thing 99% of the time. So there's always a 1%, isn't there? So 1% of the time when the CX packet weights accumulate very fast, this can be bad. So let's talk a little bit about that. So if that's happening, there's an uneven distribution of work being done by some of the threads in the parallel operation. So maybe some of the threads are completing faster than others because they're on different processors, right? So when that happens, these CX packet weights accumulate very fast. It could also mean one of the threads on the parallel operation is being blocked for some reason. And we should probably dig in to find out why that thread is being blocked. It doesn't mean you set the MAXDOP to 1. Setting the MAXDOP to 1 means you remove SQL Server's ability to parallelize queries on that instance. Not just a database, this is an instance level setting, and this is a bad idea. So let's take a look at where this is done. Here we've got our SQL Server. We right click, we go to Properties, we go down to Advanced, and at the bottom of the Advanced setting you can see we have our parallelism. So instead of, well, we'll talk about this in a minute. So you can see I've set the cost of threshold for parallelism to 50, and I've left the max degree of parallelism, which is the default 0. That means that all the processors in the box can parallelize queries. Once you set this to 1 and you hit OK, you said all the queries in the box can't be parallelized, can't use parallelism, and you've the majority of the time have done a great service to the queries on that server. So do some further analysis. Let's find out why they're spinning up these CX packets. Let's find out why these threads are, maybe one of them blocks, maybe one of them are finished faster than another. Secondly, are there page IO latch weights associated with these high CX packet weights? If you see a lot of page IO latch weights associated with CX packet weights, then there's a good probability or a good possibility you have some table scans going on. And you should be able to tune those table scans. So instead of removing parallelism, let's do a few things first. Let's use the MAXDOP hint on specific queries to control them. Let's also increase the SP configure option cost of threshold for parallelism so that the shorter queries don't run in parallel. Let's tune the workload of the instance, not just one specific database. So often you'll have someone, from a part of the organization say, the database on server X is having problems. And you say, okay. And they say, we want you to tune the database on server X. And you go and look, and there are 40 databases on server X. And they only want one tuned. Well, it doesn't work like that. You tune one, but that's good. That's fantastic. You tune the X database or whatever database they ask you to tune. But there are 39 others on that box that are sharing the resources on that instance. Okay, so when you go to tune, when you go to, most of the time it's going to be index tuning analysis or performance tuning using query plans and so forth. You're going to need to tune the whole instance. Why? Because they all share the same subsystem, they all share the same memory, and they all share the same CPU. And lastly, take Paul Randall's course on Pluralsight, on weight stats, because you can get so much information from this. It's the best course out there right now on weight statistics, and he actually goes through in graphical form how parallelism works, how these threads build up, and what to do with it. So the advice I can give you is, I would like to give you, and I hope you take, is that don't touch MaxDOP. That should be a last resort. And challenge people that say it should be a MaxDOP. If they say it should MaxDOP, say, well, why should it be at MaxDOP of 1? Why are you going to limit this instance's ability to parallelize queries? A lot of canned applications seem to be doing this. I'm not sure why, but you'll see in the documentation, one of the documentations for the last, I would say 3 or 4 of these canned applications I've installed at different client sites have said put the MaxDOP to 1. And if you are skilled, hopefully you are skilled at query tuning, don't do that. Take these steps first, and then as a last resort, set the MaxDOP to 1. And I would say the majority of the time, you're going to be able to tune your way out of having to set the MaxDOP to 1. I would say rarely, if ever, should you set the MaxDOP to 1. All right, thanks for watching.